climate change, rapid decline in fossil fuel reserves, and difficulties in the electrification of rural areas and emerging.
所以不用燃煤，不用燃油，它具备环保跟节能减碳的优势。特别在偏乡的部分，它减少很大量的运输成本。那另外，它是可以并网来运转，当电力系统故障的时候，它也可以独立运转。所以，对于提供一个区域里面的紧急用电，比如说通讯系统或医疗设施，它具有稳定供电的这几方面的优势。
The smart microgrid generates power autonomously for a local area, connected to the energy storage system, load, and the utility system. In utility on-grid mode, the load will primarily be supplied with renewable energy. Excess power can be stored in the energy storage system. In the case of island mode, where the microgrid is not connected to utility power, the system will carry out load demand control based on power situations of the renewable energy generation unit and the energy storage system. The microgrid system can smoothly transition between power modes without interrupting power supply, achieving the goal of stable energy generation, energy conservation, and carbon reduction.
所以它可以跟大型的电力系统共同运转。那一旦电力系统因为天灾发生故障的时候那它也可以切离这个电力系统独立运转，这个就是防灾型。那另外一个是在离岛或偏乡，你电力系统没有办法到达的地方，那这个叫独立型，它本身就独立运转，它独立供电，也不依赖电力系统，所以基本上有这两大类：独立型跟并网型。然后大同这两边都有很丰富的经验。
我们这个实际已经遍布在从台湾的台东、太平岛、东沙以及七美岛这些我们都有涉猎那在海外的话，从这个杜拜、缅甸以及印尼还有这个菲律宾离岛这部分，我们都微电网的一个建制，提供这些重要的设施以及容易停电断电的一个区域，来提供他们一个稳定的一个供电系统。随着未来这个再生能源的不断的一个部件，那我们电网会面临到间歇性的能源冲击。那我们大同这边提出的解决对策，就是透过储能系统来缓解这个冲击的一个影响。那我们在2021年会建置5 MW 的储能系统，来参与这个新兴的电力辅助交易市场。
大同今年已经102年了。过去70年来，大同参与台湾所有的电力建设。大同会秉持着工业报国的精神继续为台湾社会尽上一份心力。
Hi everyone, I am Chen Yenhaw from Taiwan Institute of Economic Research. Today, we are very happy that we have the opportunity to talk about the integration of renewable energy and the smart energy storage system. Here is the outline of the sharing today. Firstly, we'd like to talk about what is so-called Future Energy System 2050. Then, we will talk about our low carbon energy mix in Taiwan, probably talk about in 2050. Then, because we have a set up target, so we have some regulation and mandate about renewable energy and energy storage system. And then I will share in some demonstration or experience about the integration of smart energy storage in Taiwan. We will cover about building, e-scooter, and power system. And finally, we would like to share in the process of how to innovate the intelligent green energy. So firstly, we'd like to share the vision of the so-called Future Energy System 2050. I think recently, not only in Taiwan, but around whole world, actually the promote of utility scale renewable energy develop a lot. That is because from this slide, we can see that even the solar photovoltaic their generation cost is become relatively lower, and also the onshore wind, even the offshore wind, their generation cost is starting to decrease. And probably those renewable energy technology, their generation cost already could competitive with the coal generation or even the gas generation. So that's why lots of the new renewable energy project is being developed or ongoing in the world. And we can expect that electricity it become more and more important because most of the country looking for a better life quality, and the industry also purchase for the automation, so that the electricity will become more important in our world. So we can expect that in 2050, probably electricity, the portion of electricity will increase a lot. And the most exciting part is the renewable energy become the mainstream of the source of electricity or energy. And here is another trend that probably going very fast is about the energy storage system. We can see that now around the world, more and more electric vehicle is already promoted in the world, and there is some assumption that if the electrical market grows up continuously and the battery price will reduce 50% each 5 years, that also means we can using energy storage will become more cost is effectiveness. So I think most of you probably already see that in some country in a microgrid, there's using a lot of battery already, and also for the emerging backup. But actually in Taiwan, now we also have some huge battery promote project to try into using the battery in substation or feeder, or even try to have some impact to the frequency of the power system. So we can expect that actually maybe after 2030, the customer, they also would like to install battery to improve their power quality, or even to join the stability job or ancillary service of the power grid. And integration is very important because we know that the world is going through so-called the digital transform in the world today. So digitalization will help us to integrate different kind of resources of energy. For example, electricity system, gas system, liquid fuel system, heating and cooling, and the new energy carrier. We talk about hydrogen, green hydrogen, also will join in our energy framework, so that these 5 energy individual system will become a mainstream in the future. And we need 2 platforms to optimize the integration between individual energy system. So we need smart energy integration platform and the business model operation platform. Based on these 5 energy system and the 2 platforms that will construct our so-called integrate energy system for the future. And here is the structure of the so-called smart energy integration platform. Probably we will have more market player, and then different layer. For example, the market layer, the communication layer, and the physical system layer and the digital infrastructure layer. So if we looking at the recent progress about our energy system, we see that we have the smart meter, we have so-called whole system dispatch ISO, but now more people talk about, or more utility talk about a distribution level energy management system. So, and also new communication technology is also be involved. For example, previously we used about 5G, Wi-Fi, and now more and more talk about the so-called IoT communication. For example, the 5G. All those new technology probably will also join to construct the smart energy integration platform. And we can conclude that what is the future energy system look like? I think I always say we can say that we will have a so-called more green and more intelligent energy system in the future. We can expect more distributed generation and storage will be involved in our energy system, and the digitalization solution such as network connection measuring, control regulation, communication infrastructure, mobile network, big data, cloud computing, learning system, artificial intelligence, etc. Those technology will help or be merged in our energy system, not only in utility, but we can also expect in customer side. And then I will talk about a 2050 Taiwan low carbon generation mix. This is the previous energy demand scenario in Taiwan. We expect that our electricity demand increase probably 1% per year, but recently, since the strong demand from the semiconductor, so that probably our annually energy demand will increase probably 2%. And we can see actually in Southern Asia country, or even in China, or even in Japan, probably the energy demand will continue to grow because of the better life quality demand, and also the precise industry manufacture. And here is some fundamental character, say, for the low carbon generation mix. We can see that according to the IINA report, I think we shared with you previously, the utility scale PV and onshore wind will provide lower price electricity, even cheaper than the new coal-fired power plant or oil and natural gas options. And also, I think this is a vision is not only shared in Asia, but also in Europe. They also had tried to, in Germany, they also decided to phase out the nuclear and the coal-fired power plant before 2040. And in Taiwan, we have a so-called nuclear-free homeland policy. And now it's very difficult and challenge for government to try to install new coal-fired power plant. So we can expect that in 2025, our energy mix will become maybe 20% renewable, 30% coal, and 50% natural gas. And we will increase the portion of renewable and natural gas. And so that we can expect that in 2050, we expect that we have 40% of renewable, 5% of coal, 55% of gas. But recently, our government also announced that Taiwan starting to doing the so-called net zero transformation. That also means in 2015, we are looking for net zero emission in Taiwan, so that our government now is on the way to try to figure out the new pathway to help Taiwan to reach a net zero in 2050. And we can see that if the power system have more renewable energy in Taiwan, we have the target for renewable now is main develop is solar and offshore wind. So we can see that actually all those renewable energy have so-called seasonal or daily variation and uncertainty. So for our popular power system, the challenge will come from the dynamic generated character of the wind and solar. So if we see the net load, the concept of net load is the total electricity demand in the system minus wind and solar generation. So we can expect in Taiwan the same thing. In Taiwan, we have a very strong character of season. Usually in wintertime, we have very good wind condition. And the summertime, we have very good solar, so that we can expect that in the future, we will have a so-called very dynamic net load shape, and that probably will be the challenge for the utility. They need to stabilize the power supply and demand. And so we can some lesson learned from the California ISO or even in Taiwan. We now more focus on increase of the flexibility resources. We like to use the new resources, for example, the battery, for example, the demand side control, or even the diesel generator to become the flexible resources to join the service for the power grid. And the storage mandate, we make our policy target about the installation of storage. And also, we also initiate our scheduling, market design, and we also have so-called not exactly the balanced market, but we try to have the so-called ancillary service market, and we also try to move the time of use pricing system, because previously in Taiwan the peak load is in the noon or in the afternoon, but since we have installed sufficient photovoltaic, now our peak hour is moved slowly, gradually to the evening, so that will become also a lot of challenge for our power system. And there's here is the Taiwan Future Power Dispatch Framework concept. Based on this concept, we starting to construct the platform needed in our power system. For example, now we already have so-called green energy trade platform, and this year we also try to have in the ancillary service platform. And in the long run, our government is on the way to design the power trade platform. And for the demand bidding platform, we already construct this platform for several years, and this platform running very well. It really helped the Taiwan Power Company to integrate the resources from customer user side to help to the management of the power system. And we also can expect that in the future, we probably also will have the so-called regional ancillary service platform to help to stabilize the power quality in distribution level. And these platforms would like to integrate, for example, would like to encourage maybe the ancillary capability of renewable energy power plant, and we also have so-called city-level virtual power plant. And this power plant also will be integrated to the power system through the regional energy integration system. And now we have more and more so-called energy storage is being connected to our power grid already. So we can In microgrid in Taiwan, we have a lot of remote island. Actually, most of remote island already installed an energy storage system. So now we use the experience in remote island or remote area. Now we try to using the energy storage system in our distribution network. And the digitalization is not only happen in the so-called utility side. This is the virtual power plant structure now we have using in huge energy consumption customer or the Taipei city government. We use this integration system. We have 3 level. First level is so-called site level. So we have site platform and we have aggregation platform. Then we have the whole energy management station. With this 3 level, we integrate individual resources to join the grid operation platform. And if you have any interest in, we can try to link you to see what is the so-called Taipei city energy management system. In this power system, we have very clear 3-level demonstration. Now we like to talk about renewable energy and the energy storage system related regulation and mandate in Taiwan. In 2017, we have opened our energy market because more and more enterprise in Taiwan trying to sourcing renewable to increase their usage of renewable energy to better in the performance in the ESG area, so that more and more enterprise trying to using more renewable electricity. And so that we have opened our renewable energy market. Now in Taiwan, the enterprise could sourcing renewable directly to negotiate with the renewable energy generator, or they also can ask the renewable electricity retailer to help them to deliver the renewable energy. And the Taiwan Power Company will help those renewable energy generation to willing to deliver the power to the renewable energy end user. Now, most of our government think that, or people think that the large electricity consumer, they probably need to take the responsibility so that we have some mandate for the large electricity consumer to ask them to using green power or purchase T-REX. So according to the strategy environmental assessment for new science park, the enterprise, they need to commit about 10% of their contract capacity should be come from renewable. And in our Renewable Energy Development Act, the Article 12, actually we also given this obligation to the large electricity consumer. That means if their contract capacity is over a certain amount, at this moment is about 5 megawatt, then they need to install renewable energy generation equipment about 10% of their contract capacity, or they can install energy storage, or they can sourcing renewable and T-REX together. Of course, if they do nothing, then they need to pay the penalty, and the penalty is about 4 NT per kilowatt hour at this moment. Most of the enterprise in Taiwan, they really care about their reputation, so that in Taiwan at this moment, more and more enterprise looking for solution about battery storage, renewable energy installation, or they also join the renewable energy market to trying to sign a corporate PPA to help them to meet the requirement. And about the battery, we also have some opportunity. For example, in our regulation about governing reserve power supply capacity, that means for the power generation industry or the renewable energy retailer, if they sell the power to the end user, they should prepare for they should prepare additional power supply capacity as a so-called reserve power supply capacity. This regulation, I personally think, also will help the power industry to install more energy storage system and to play the role like the stabilize the power grid. Here, I would like to share some experience in Taiwan about integration of smart energy storage system. The first one is building, then e-scooter, then the power system. For the building or science park, actually we now talk about the customer side. There's a new concept from the United States is so-called grid optimal building. This is talking about if we, as a role, a consumer in the power system, the building, and we need to take the responsibility to help the grid operator to stabilize the grid, so that the building you should install photovoltaic or electric vehicle, smart meter, storage, or you need to do the energy management system, so that the power consumption of the building can really work together with the power grid situation. And here is the concept that the building, for example, because in Taiwan, we probably has the same weather during the summertime like other Asian country, that we have very hot, warmed season in summer. So we need a lot of air conditioner, and the air conditioner usually energy consumption about 1/3 of building in Taiwan. So if those buildings could install so-called thermal battery, the chiller work together with the thermal storage or lithium battery, and the energy and adjust its power consumption based on the TOU pricing, that probably will really help our power grid to maintain their so-called load factor become 1, and of course those situation also depends on the renewable generation, so that the renewable generation, power consumption, and our devices in the power grid should work together. Then I'll talk about the e-scooter. Here is the e-scooter, now very popular in Taiwan, the so-called Gogoro. They are the battery swapped system. And now in Taiwan, we have a lot of those kind of battery swap station. Probably in each kilometer square, you will find at least one this battery swap system, the station. And so that we are now thinking about using those resources to help to stabilize the grid. For example, here is an example. We can see the green line is the so-called charge curve. Usually, the battery swap happen is in the early morning because everyone commute to the work. So a lot of battery without electricity will be pushed back to the power swap station, and they can charge during the morning time. They can charge the battery, and they can deliver the power in the afternoon, so that they can really help to the demand response for our power grid. I think that is one model to integrate the electric scooter and the power grid operation using the swap battery stationary station. And finally, I would like to talk about the power system idea about the integration of the energy storage system. And here is the ancillary service needed by the Taiwan Power Company. We can see that in the future, since the more and more photovoltaic, onshore wind and offshore wind farm is connected to our power grid, so we need more ancillary service resources. This service could come from traditionally come from the AGC, from the gas combined cycle, and also the hydropower. But now we're really thinking about using energy storage system to help. So we have set up the target about 590 megawatt ESS system should be installed in Taiwan. So the construction job is ongoing every day at this moment. And Taiwan Power Company, they trying to define different kind of ancillary service item and looking for help from other operator, from other supplier. For example, they have defined so-called fast response reserve, regulation reserve, spinning reserve, and a supplemental reserve. All kinds of reserve have different response time and duration, depends on their role and their function to the power grid. We have defined different kind of so-called commodity or ancillary service, and the supplier can using different kind of resources to deliver that kind of service to Taiwan Power Company. For example, they can use storage system, they can use demand response, they can use self-use generation equipment, etc., to help to stabilize the grid. That also means more and more distributed generation equipment will be joined in our power system, and they will be linked to our energy management system. Here is just a very quick example about automation frequency control. Actually, last year, Taiwan Power Company has seen tender for about 25 megawatt AFC capacity, and this AFC control really demonstrate their function recently, because recently we have a very strange weather. We have the highest temperature in May. It's never happened because of the climate change, because of the climate emergency. So, but all those automation frequency control systems really demonstrate their function, help to stabilize our power grid. And here is some demonstration of the renewable plus energy storage system in Taiwan. I work together with Tier, with Datong, with other company in Taiwan. So if you have any question about the energy storage system, please do not hesitate to contact the Taiwan company. I think they also very willing to help everyone. And here is some new idea about how to integrate the customer and the developer of the solar, wind, and the energy storage system, so-called community project. We also think that will be a good idea to help to create more resources for power grid. Finally, I would like to share with some experience about the intelligent green energy innovation process. Taiwan, we have a so-called National Energy Research Program, I think in the past 10 years. And during this period, we have go through the so-called Intelligent Green Technology Innovation Pipeline. This is a demand-driven idea. So we integrate all those Taiwan Green Energy Innovation Challenge to integrate the university, national laboratory lab resources, and to create any new idea from research, idea, and a business plan, and prototype, pilot demonstration, commercial demonstration, and the market really adapt. Through the process, we have created, for example, the microgrid technology, distribution energy management system, and city level energy management system, and also the WAMS area, the PMU, etc. So this is a very useful pipeline for really innovated any new idea about green energy. And why this idea is important? Because we know that many places have their own the local social economy level, different level, and the technology developer and the resources. So that I personally would like to really encourage anyone, if you have any new idea and you're trying to demonstrate that locally, I think Taiwan could be the partner to work with you, to help each other, to work together, to demonstrate your idea in the right places and then create any new opportunity. I think any Taiwan research laboratory, university, or even our industry partner, we like to work with you looking for better life quality and also the more stable power grid system. So that is all the content I would like to share with you. If you have any question or idea, please do not hesitate to contact us. Thank you very much. Thank you for your join today. Thank you.
Ladies and gentlemen, I'm Changping Lin from Tatong Company. My job title is Senior General Manager of Smart Energy Business Unit, and I'm also the Deputy Director General of Overseas Business Strategy Division of President Office. Today, I would like to talk to you about the topic of smart grid development and applications, which is of great importance regarding the modernization of power infrastructure for every country worldwide, including your country and my country. First of all, I would like to say that out of many people's imagination, the greatest engineering achievement of the 20th century, cited by the National Academy of Engineering, was electrical grid, not mobile phone, not the internet. It is the power infrastructure. Electrification supposes the development of economy and the necessary function of modern society's daily life. Without electrification, even the mobile phones or the internet would not exist to provide their convenience for today's civilization. Considering this greatest engineering achievement of human society, there comes two critical issues that each country need to carefully deal with. That is, the first is energy policy, and the second is the industry strategy. We will have more discussion regarding these two critical issues later. Before the introduction of smart grid, we should have a review on the so-called traditional grid. The nature of the traditional grid is it is of electrical infrastructure only. It consists of backup generation, such as nuclear, coal-fired or hydraulic power plant, and the transmission and the distribution networks, substations, such kind of electrical infrastructure. And the box generation are away from the laws, such as communities, cities, or industry park. So we need to build expensive and take much of the time to build the transmission and the distribution network to deliver the electrical power from the location they were generated all the way down to the place the load located. So it takes time and expensive, especially for the transmission and the distribution grid. The characteristics of the traditional grid is that the power flow is one way only. It is from the power utilities to the customer. And there is only one way communication used in the monitoring of the operation. Finally, there is no involvement of end user and also lack of customer information. So there is no any interaction between the end user and the utilities. Such kind of traditional grids, it faces to some problems. That is how it to meet the diverse requirement of 21st century's world. For example, for the global warming and a critical climate change, how to meet such kind of requirement. And the growing of GDP require more and more stable supply, and there are many rural areas. They need electricity infrastructure also. So how it to meet the diverse requirements of the 21st century's world? I think the answer you already know is the smart grid. The smart grid, shortly speaking, is the grid modernization, and it provides a lot of opportunity for both R&D and commercial business activities. The nature of smart grids is no longer pure electrical infrastructure. It integrates intelligence infrastructure into the original electrical infrastructure deeply to become a new generation of smart energy infrastructure. And there are several key features about this new kind of generation. First, due to the introduction of DER. DER means distributed energy resource. Due to the introduction of DER into the distribution networks, the power flow becomes two-way. For example, you can build your own PV, and you could set up a small wind turbine or battery in your household and generate electricity for your own use. And the electricity, the power energy, not if it is more than you need, you could store the electricity to your neighborhood, or even sell the electricity to the utilities. So the power flow becomes two-way. DER transforms the original infrastructure in different levels. level. Because of the original grid-in architecture and also the facility and the device they used, they were designed based on the one-way power flow. So the DER transformed the original infrastructure. There are so many facilities and the devices need to be modified. They need to redesign to satisfy the good requirement of two-way power flow. Most DER are of intermittent in their nature, and such kind of nature will impact the stability and the operation of the grid. So we need to develop a lot of innovative technologies to deal with such kind of uncertainty in the supply of electricity and manage the grid to keep the power quality good enough. So this would be a revolution for the traditional technology. And the second, the intelligence infrastructure make use of a lot of state-of-the-art of information and communication technologies. And it also introduces the risk of cybersecurity. So this is a new kind of issue the smart grid need to take into consideration. And the third, it is electrical vehicle. EVs play dual role in this new infrastructure. EV could be a load, or also they could be a special DER. The difference between electrical vehicle and the traditional DER is that electrical vehicles are mobile. If you set up a PV in your household, it is fixed. But your electrical vehicle, it is mobile. The management of the grid operation becomes difficult due to the interaction with so many EVs introduced into the grid. The variable and the mobile load and the energy source could make the operation of the grid even more difficult. In summary, we need innovative solutions, innovative technologies, and even innovative grid architecture with cybersecurity to be considered in mind, and with many heterogeneous helps from different fields. Namely, it is called AIoT. The introduction and development of smart grid involves so many technologies in diverse fields, and it concerns a huge investment both for government and for industry. So it should be planned and done based on the unique conditions of each individual countries. Different countries has his own different consideration and focus. For example, the United States focus on improving the reliability and efficiency for their aging grid and the facilities. To defer the extra investment and extend the lifetime of their assets, the U.S. government also put demand response as another focus. Besides, because in the internal combustion engine, the traditional car are one of the major contributors of the carbon emission. The promotion of electrical vehicles become one of the solutions to carbon reduction. These are the major focus of the United States. The 4 other countries, like China, their considerations are totally different. They have a lot of natural resource in the area of north and east area, but their load center are located in the eastern and the south part of China. So their major focus is to build a strong long-haul transmission line for thousands of kilometers to deliver the green power generated in the west area to the east area. So this is the focus of China. So before doing the smart grid planning for your own countries, there is one critical question you should answer. What item in smart grid you should be focused first? This slide shows the business scope of smart grid. You should find that smart grid is the kind of cross-industry business. It involves power industry, information and communication industry, PV and wind power industry, EV and transportation industry. And finally, energy storage and ESCO aggregator business. For such kind of cross-industry business, there comes several critical issues you should concern. Number one, what are good business models for your own company? And 2, how to make successful cross-industry system integrations. You need many strategic partners from different fields. And number three, what are the derived application and the service for new business opportunity? Smart grid is only the infrastructure. What kind of application and service you could provide upon this infrastructure? For example, Internet itself is only an infrastructure. But Facebook, Google are application, very successful applications and the business model upon the Internet infrastructure. And what are the derived application and the service for new business opportunity you could provide? Now I will put Taiwan as a special case for the discussion about the development and application of smart grid for your reference. This slide shows the electricity supply structure in Taiwan in 2016. You can see that renewable energy is about 9.4% of the total installation capacity. But for the generation, renewable is only about 4.8%. Taiwan government set an aggressive target for promoting renewable energy to deal with carbon reduction issue. The target of generation combination in 2025 is that LNG-fired 50%, coal-fired 30%, and renewable 20%. such aggressive target, there comes several critical issues for Taiwan government and the industry. The first is that how to achieve the target. And the second is how to manage the installation, distributed energy resource everywhere. PV and wind power. For the wind power, the wind farm is large in one site, but for PV, they were distributed around the island. Because of the limited land area in Taiwan, the renewable were distributed everywhere in Taiwan, including rooftops, wasteland, ponds, and so on. And the renewable are of intermittent in nature, so there it becomes a critical issue for the current power grid. This slide shows the base load versus peak load in Taiwan. You could find that the peak load in winter time is only about 2/3 in summer times. This means that in 2025, we don't have enough stable base load in summertime and must be rely on unstable renewable. And we will have too much renewable during the winter time. So therefore, the critical topic we will face are two critical topics. One, how to deal with the intermittence of the renewable, which would impact the stability and the quality of the supplied power. And number two, 20 gigawatt renewable plus EV fleets afterward would change the profile of the peak load and off-load demand. What are the solutions? In 2025, the supply during the rain time in summer will be enough because there are 14 gigawatts of PV, but it would be trouble while sunset. Traditional generations could not catch up during this short period of time. The load demand has changed. So we are now dealing with this issue by ancillary service provided by energy storage systems. Actually, all of these questions do have answers. That is smart grid with AIoT. And we need reasonable mechanisms. It means that we need to revise the regulations and we need to set up new criteria and new rules. And finally, the most important thing is the determination. We need to believe that these are the right solutions. This slide shows one special application of smart grids. It is so-called microgrid. It is a micro-sized power grid. Microgrids consist of DERs, such as PVs, small wind turbine, and biodiesel. We put DER as the major supplies and put the traditional diesel generator as the final backup. Microgrid is equipped with advanced energy management system, which has advanced control algorithm make the grid operation smooth and stable, because the major supplies are of intermittence in nature. Microgrid is especially suitable for isolated islands and rural areas that lack of electrical infrastructures. For the undeveloped area, for example, in Myanmar, there are more than 20,000 villages lack of electrical supply by infrastructure. And there are some remote mountain area also lack of supply from electrical infrastructure. So it is very simple. We put a microgrid there to save money and time to build the transmission and distribution grid. For the isolated remote islands, microgrid has the advantage of saving fossil fuel. The cost of the fuel is low, but the cost of transportation is very high. Philippines has more than 7,600 islands, and Indonesia has about 17,500 islands. Microgrid is a good solution for those islands for reducing transportation cost and providing stable electrical supply with clean and green energy. Furthermore, microgrid could operate with connecting to the main grid and disconnecting from the main grid to operate independently while main grid fails. Hence, microgrid could enhance the reliability of the electrical supply for some critical applications, such as military facilities and disaster prevention. This slide shows the architecture and the application scenario of microgrid. Microgrid technology, especially the energy management system, algorithm they used, should be capable of handling the critical issue, such as, number one, the management of the unstable DERs. Number two, manage the coordinated operation with and without the main grid. Number three, manage the energy storage system to stable the operation. Number four, operation smoothly with many EV and handle the V2G function as well. Number five, able to work with heterogeneous systems for VPP business. And number six, embedded with the data analytics capability to support many value-added services. This slide shows the application scenario of one key component in smart grid, that is energy storage systems. Energy storage system could be used in large-scale renewables to stabilize their output power, and it could be used in substation to perform the frequency regulation, and it could be used in microgrid for their stable operations. And also, it could be used in commercial building or residential house for backup power. And it could be used as the trading tool for business. This slide shows the diverse application scenario and the use case of energy storage for your reference, just as I mentioned previously. This slide shows the scenario of demand response applications. All technology and applications we had discussed are all from the supply side point of view. Actually, the stable operation of the power system depends on the balance of supply and the demand side. Demand response could respond to the supply side issue, such as generator trip or failure, very fast. Demand response could be used for load shift for supply side and could be used as the business tool by demand side. Demand response could be of much value for demand side management while working with energy storage system. And this slide shows the scenario of electrical vehicle charging applications. The critical topic we need to consider, including how to manage charging cycle to cope with the battery safe and the battery life. And then need to consider the management of operation and maintenance. This slide shows the challenge of charging the EV fleets. Since the traditional grid never considered such kind of application, the smart grid must be planned with EV fleets charging and V2G in mind. This slide shows the PLC project in UK. It shows that there will be two bottlenecks in current distribution network. Number one is distribution transformer might be the bottleneck. And the second, distribution feeder the next. So when we plan the smart grid, we need to take this challenge in mind. Finally, due to the line limitation, we should stop the presentation now. I sincerely hope that this presentation could help you to catch some key idea of smart grid and encourage you to work for this field to make contribution to the grid modernization for your own country. Thank you and bye-bye.
Hello, my name is Rita Lin. I'm from Datong Company. I am special assistant to Senior General Manager CP Lin. We are in the Smart Energy Business Units. Okay, in this session, I will introduce you Datong Company and our business in smart energy. So by looking at this slide, this is our business. We have established, Datong Company has established since 1918. And over this 100 years, we are multi-business entrepreneur. And in this multi-business, we have devoted not just in power industry, but also home appliances like washing machine, TV, and the aircon, etc. So back in power business, we are very active since 1949 to 2000. Over these 50 years, we have developed the power equipment providing and the supply to the markets. At the highest peak of the business, it's in 1949. It is for the industrial motor. The market share was about 75% in that time. And then the next thrive business we had is in power transformer. That's in 1950. And with that time, we have already to have a close relationship with the power company in Taiwan. We call it Taiwan Power Company. In the power business, we're not just providing the transformers, we are also providing the high voltage GIS, gas insulated switch gear in the power plants. And also to the customers, we help the power company to provide the mechanical meters. And through this 50 years, we have built up a strong experience in the renewable. So in 2000 to 2021, over this 20 years, we started smart energy solution. For instance, like at present, you can see the presentation below is the solar system, microgrid system, big data AI application, and all the way to the national scale of energy storage system. In Datong Company, in smart energy, the product and the solution we provide, not just the system integration, but also the solar solutions all the way to the microgrid solution, so that our business is B2B. We are partnering with the EPC companies or civil engineer companies that we provide the solar power system to the customer services. For instance, that the solar is one of our concentration, and we are matching with the system with the energy storage system. So in this product and the solution, we are combining the equipment and the solutions together for the customers to realize that Datong brand is worldwide. And through our partner, we are localizing our systems in diversified technology solutions. Next slides. We have over the 20 years experience, we have many cases over the world, including the ASEAN countries. For instance, that we provide 3 solutions. One is the off-island solution. Another one is the household residential off-grid solution, and all the way to the national scaled microgrid solution. For instance, from the table, the first table from the left-hand side is the residential case. In Pingtung, the southern part of Taiwan, we have called up by the local government that the mountains aboriginals, they are out of the electricity. So in this case, we have designed and built the microgrid system for this off-grid case. So in this case, we have designed smaller capacity of solar power system at 2.5 kilowatts, and also with energy smart with 15 kilowatts hour of the energy storage system. We combine these two to support the operational at the house for the lighting and the electricity supply. And with this energy resources, we're not just for the solar, but also we have installed the little small wind turbine together to back up with the solar power. So in this case, this house, although is off the grid, but can have 100% of the renewable solar for the renewable energy. The next that I mentioned is the off-island. For instance, the second column, you can see it's a disaster prevention. This is also caught up by the local government from Taiwan. It's in Taipei County. In the Wulai district, the district was also tried to prevent to prevent the blackout, because in Taiwan we have typhoon. So in this case, we have design the small little energy storage system to back up this government requirement. So the design is 18 kilowatts for the solar panel, and 60 kilowatt per hour is for the energy storage system. This is just for the support of emergency and the living electricity. And then so on, you can see not just the villages, but we are also go to the abroad, like in the small islands. For example, you can see from the fifth column is the Taiping Islands. This island is also trying to have this renewable energy to be used. And according to the government requirement, this island is off-grid, so it's seeking for 100% of renewable energy and reduce the fossil fuel. So in this case, we have designed 160 kilowatt solar power with 612 kilowatt per hour storage system to combine together to supply the power to the locals and also the militaries. The next is the water and the electricity. It's this project is in Dubai, and the Dubai is the desert region, has no water. So in this case, we integrate of the water pump with the solar power system so that the locals can get the water from this system. And for this water generation, it is about 200 liters per hour to generate the water for the locals. In this case, this is also rewarded in 2016 as a system integration awards in the Smart City exhibition. The next one, the last one, is in Kaohsiung of Taiwan. It's in southern part of Taiwan. And this is a national scale. And this is also the Taiwan first, the largest scale of energy storage in Taiwan. In this case, we are put all the our capacity to make a national-wide design of 1.2 megawatts of the storage system. And we are also have the manpower to do the power smoothing and stabilizing the power voltage and the frequency to regulate this power supply, and also reducing the reverse of the power. And we are also scheduling with the Taiwan Power Company that the power supply can be stable. Next slide. As in Datong, we have been served this smart energy field for 20 years. The scope in the solar business, we are not just providing the energy storage system or the microgrid, but we are also designing the solar power system. For instance, like the rooftop or ground mounted or floating type. It really depends on the customer needs, that these three is flexible and to be installed. In Taiwan and over the world, our experience of installing the solar power system is about 170 megawatts as the performance brackets. And we are still in this business and still grow up. In the future time, we are looking at more like 200 megawatts in the future time. And then the next is because we have the solar design because we have the solar, we are devoting the solar power business. So the solar power, we have applications to fit in, for instance, like a microgrid or the solar water generator. It also depends on the customer needs, and it depends on the environment. The last one is the solar power plants. and it maintained that we are doing the monitoring system, as we are not just the equipment provider, but also the system design, that through the software and the sensors and also the connection of AIoT, we are making our own solutions for the monitoring system. We collect the data and we also do the backstage analysis. And also, when we provide this system, we also provide the OEM services. Next slide. In microgrid, we have also did a lot of projects, and our initiative and the vision is built on our customer needs. For instance, like lack of infrastructure, or save the fossil fuel, or to enhance the reliability electricities. In this case, in these three cases, we are trying to help our customer in undeveloped area or in the deep mountain, lack of infrastructures. We provide the microgrid with energy storage system. We're trying to help to provide 100% of renewable energy to make a power supply. The next is the fossil fuel. As islanders, they wanted to reduce the usage of the petrol from the diesel engines. We are also put the energy storage system with the microgrid to be controlled that the power supply by the diesel engines can be reduced by using the fossil fuel, but using the renewable energy. The next one is the customer who is seeking the reliability power supply. It's like a military. When they have a terrorist attack, they are trying to prevent the blackout or cut off from the electricity. They will need this the power supply, renewable power supply micro system. So in this case, we provide this energy storage system to the government institutes. Especially, we will put the disaster prevention in the case. Next slides. So now I will beginning with the cases, as I just mentioned so many case studies from the above, but in deeply, I will start with Myanmar as a case one. So due to Myanmar is the utility power grid penetration is not that penetrated. It's only 65% of penetration rates. So in this case, we have made a smaller microgrid design, like a PV system. We designed 10 kilowatts, and the water pumping is 6 kilowatt. So putting these two equipment, we are making into the water pumping solution without the utility grid. So in this case, many villages has no electricity, and with our water pumping solution, the villages is being able to get the water for this with the renewable energy. This is also helping that the governments to reduce the fossil fuels, and the villages can also be able to use the renewable in order to overcome the lack of infrastructure. Next slides. In the case two, this is happening in Taiwan. So this is called by Pingtung County government. The local governments, they're also seeking for 100 penetration of renewable energy. So therefore, in this case, we have designed 159 kilowatts energy storage by using the Li-ion. And also the PV system is 78 kilowatt per hour. and kilowatts per hour installed capacity, and also with the wind at 10 kilowatts. And we are also putting the energy management system to control the whole system. So in this case, the government has also also rewarded to our company in 2015 APEC ESCI as an energy smart community initiative. So by using this 100% of renewable energy, the government is being able to cover the locals with 100% of renewable energy, and also sometimes depends on the weather, climate change, that the typhoon is regularly being hit by the typhoon. So the disaster prevention is also included in this project. Next slide. Then to the case of island-based. So this is one of the case study, and this is called up by our government, the Coast Guard Administration. This is happening in Taiping Island. This island is also being cut off from the electricity. It's not it's not well infrastructured. So in this island, we put energy storage of 612 kilowatts, and this it is made of lead acid, and the PV system is 160 kilowatts with a diesel generator as a backup system. So this PV becomes a main energy source in this island. And this is also being used by the Coast Guard Administration as the power supply of the islands. As you can see from the picture, how the ground-mounted solar is being installed in this Taiping Island. Next slide. Another island case is happening in Philippines. And this is one of our overseas case is still going on, and we would like to build up for furthermore with the Philippine government. This location is in Limasawa Islands. In islands, as we just mentioned, it's lack of infrastructure of the power. So energy storage for this case, we have designed 167 kilowatts in Li Ion. And PV is 120 kilowatt, and diesel generator is the backup system. So this is a main energy system, a main energy source to provide the islands. In this field that we have been built up experience with PV and diesel generator and the battery together to make up a microgrid system. In the future time, we're seeking for more islands like this so that we can put this similar design to help the other islanders in Philippines or even in Asian countries. Next slides. Okay, the next slide is the disaster prevention. As I just mentioned that the Taiwanese government, sometimes they wanted to prevent the typhoon hitting Taiwan and make the infrastructure being failure or being cut off from the electricity and to have to prevent the blackouts. So in 2015, this typhoon is really hitting the Taipei County. So Wulai becomes an independent island. No electricity, no water, and there's been cut off from the world. So in this case, in 2016, we have made the Wulai district, the Wulai villages, the microgrid with solar at 18 kilowatt, and the solar energy and the energy storage system at 60 kilowatt. This is just to make this is just to prevent the power is being cut off, and the power system can be stably supplied to the villages. So in this case, that the government is also caught up that in case they don't have any interruptions of the typhoon and the infrastructure failure. So in this case, we are also putting the disaster prevention monitoring system to this case. And so that when we know that the typhoon is hitting and the electricity is being unstable, then this system will be triggered by this disaster prevention solution. Next slide. Then to the smaller system, we actually designed not just the nationwide or the island of Ireland. We also do the residential cases. As we just mentioned that in Taiwan, we have high mountain landers that they don't have electricity. So Pingtung County, the Pingtung County government has also called up for us to help the local aboriginals who lives in the deep mountains to have a smaller power supply system. So in this case, we have put energy storage at 1.6 kilowatt per hour, and it's made of lead acid with the solar at 1 kilowatt. It's a standalone system that the villages in the deep mountain can have this to supply to the lights and also uninterrupted power supply. So this can be also be promoted not just in Taiwan but also in the Indonesia or ASEAN, whoever has less utility developments. We can have this to supply to the villages or the people who is cut off from the utility. And with this experience, we can also put up to the capacity to the energy storage system at 20 kilowatt per hour. And then we can use Li-ion with 5 kilowatts per hour for the solar PV system. And this can be done without the gensets, the diesel generator or the backup system at the back. So this can be fully standalone to be used. And then we can also do the grid tied as well to connect it to the utility. It really depends on the customer needs. Next slide. Then from the smaller one, then I will introduce you to the national-wide. So this is the energy management system for the national megawatts large-scale energy storage. The customer is the Industrial Technology Research Institute in Taiwan, and we have picked up the location in Kaohsiung. So the installation is at 1 megawatt energy storage system. Our focus is to smoothing the renewable energy from the solar power and the voltage regulating the electricity, and also we are regulating the frequency and the scheduling, reducing reverse power, so that we can stable the output of the renewable energy into the power grid. So this is also the first megawatt, the large-scale energy storage system in Taiwan. And from the picture, you can see 4.6 megawatt of solar PV system, and with the 1 megawatt or 1.2 megawatt energy storage to combine together to do this the large-scale energy system as a national standard microgrid. Next slide. So more about this case. In this case, that Datong is also doing the energy. You can see from the structure. Datong is also providing the energy management system, so that we have a plan that in the future time we will have phase 1, phase 2, and the phase 3 to build up the larger capacities. And each phase we will have 1 megawatt for the energy storage system. So that in the future time altogether we can do more than 4 to 5 megawatts together to integrate of the several storage system, and so that we can provide also to the different vendors. And you can see that we have also been systematically designed for this storage system into different piles of the columns, so that we will tracking in different we were tracking different data from the different phases. So this is also the case together with Industrial Technology Research Institute, ITRI, with in Taiwan, and this is locally being cited is in Zhangbing in the central part of Taiwan, and the majorly that we are doing is the energy management system. Okay, next slide. So this is all the case study that I have introduced you, and thank you very much for your attention.